Hello, how's it going? In this video, we are going to keep working on our WGPU system and introduce shaders. By the way, I switched over to Mac, and the reason for that is, I don't know why, but in Ubuntu, the shaders just weren't working. And also for some reason, RenderDoc wasn't working. So I am getting a little frustrated with WGPU, to be honest, because there doesn't really seem to be a good way to debug it. Anyway, in this video, it's going to break down into roughly 3 stages. First of all, we're going to write our first shader. Secondly, we're going to make a utility file that basically is a pipeline builder, so to speak. So you can instantiate one of these pipeline builders, throw shader code at it, and it'll throw pipelines back at you. Might be a little bit of overkill at the moment, we've only got one pipeline, but I think it's a good general thing to have. And then finally we'll bring everything together and yeah, pretty much get a triangle on the screen. So to start with, our first step is we're going to write our first shader. So I'll go inside the source folder, make a new folder, I'm going to call that shaders. And then inside that folder, I'll make a new file. I'm going to call it, yeah, very imaginative, shader.wgsl. Now you'll note that when I created this, VS Code recognized that it was a WGSL file, a WebGPU shader language file. If you do not get that happening, you can just search for, what is it, WGSL, I want to say? Generally, you just search for whatever you are after. And here, the first option here, we have syntax highlighting for WGSL files. That's the extension that I've got, and that's how it's recognizing the WGSL file. Okay, so the way this is going to work is, if you've come in from OpenGL programming, this will be very familiar. We have 2 stages, a vertex shader and a fragment shader. Now the vertex shader is going to run once per corner, basically, and its job will be to output a bundle which can then be interpolated by the rasterizer, broken up into little fragments or pixels, and then the job of the fragment shader will be for each of those pixels to determine the final color. First of all, I'm going to define a function, which I'm just going to call vertex shader main. These do need independent names. We can't just call them all name, otherwise we're going to have trouble. And this function, whoop, there it is, it's going to output something, which I'll just call this now. I'll define this in a second, but it'll output some struct, and it will be the purpose of this struct to hold all of the information that the fragment shader will then consume. So on the other hand, we'll have a function called fragment shader main, which will take in an instance of that struct, and it will go ahead and output the RGB color that we should be putting on the screen at that position. Now there's a little bit more to this, but I'm going to seesaw into this one step at a time. In terms of the struct that we're passing around, passing from the vertex shader to the fragment shader, this is very simple. All we're really required to pass along is a position. So this will be, I'm just going to call this clip position, and it'll be a vec4 with components float 32. Awesome. That's it. That's all we're required. But I do want this position not just to be some random variable that I set, but to actually appear on the screen. And so I'm going to need to decorate this. I'm going to decorate it and say, okay, this is one of the built-in variables. It's the built-in position variable. And there it is. That's all I need. Cool. Now, I'm going to try to keep the job of making a shader, I'm going to try to keep that independent to the job of sending data to the GPU. That's what I'll look at in the future. So what I'm going to do now is I'm going to use constant data in my shader to set the position. So let's say I want to define a triangle as just a constant array, and then you see what I'm saying here. I'm going to define the data in the shader as a constant. Okay, so I'm going to make a variable called positions. That will be an array of these vec2s. We're going to need 3 of them because it's a, whoops, I said 3 because it's a triangle. Let's go ahead and define them. So WGPU uses the convention with x and y in clip space, so between -1 and 1, where a negative value for the x is the left of the screen, a positive x is the right of the screen, and a negative y is the bottom of the screen, and positive y is the top. So here I've defined the bottom left point. Go ahead and say, alrighty, we'll make the bottom right point. Just like that. And those are that's my data. I'm not uploading anything, that's my data. So what I'm going to do is define a variable. I'll just call that out, and that's this vertex output struct. Okay, the only thing we're going to need is to set the clip position. To do that, we'll construct a vec4. We'll need to get the appropriate position, so we'll index into that positions array. And I'm going to take in another built-in variable. This built-in variable will be the vertex index. I'll just call it I. That'll be, there we go. So when we have a draw call, we have a bunch of built-in variables available to us. One of those is the vertex index. You'll see in a second, I'm basically going to issue a dummy draw call that goes from index 0 and 0, 1, 2 up to less than index 3. And that will be passed along to the vertex shader. Anyway, so with access to that variable, we can go ahead and grab the appropriate position. I'm going to set a Z value of 0, and I'll set a W value of 1. If you're not familiar with why that is, I'll talk about it at a future point. Alright, so now we'll go ahead and make the fragment shader. And this is very simple, because I'm going to just have a constant color for everything on my triangle. So I'll return the following color. Let's go 0 for the red, 0.4 for the green, 0.4 for the blue, and an alpha of 1. And it really doesn't matter, just make up your favorite color, and that's probably fine. So let's review. We have a vertex shader, which is executed once per corner of our triangle, but we're not uploading anything, we're just using the inbuilt vertex index variable, which will then be indexing into one of these positions. But the point is, great, we just set the position on the screen, and then we output a bundle of information, this vertex output struct. This is totally up to us. The only thing we need to define, we're required to define, is the position on the screen. If we want to put in custom data, we can do that, but otherwise, look, there it is. Now we take that in and then promptly ignore it, but it does need to be there for the fragment shader. The fragment shader, on the other hand, is just outputting a constant color. So this should be like a sort of medium cyan or something like that. Okay, so that is it. That is our first vertex shader, our first shader. Okay, now for some real fun. How can we make a general shader loader? Well, one thing I'm going to do is I'm going to make a folder, and I'm going to call this renderer backend, because when I deal with multiple files, sort of the most elegant way to do it is to package modules into folders. So what I'll do is I'll define a file called mod mod.rs, and it will be the job of this mod.rs file to describe the source files which are associated with this module. So I'll say, alright, I'll have a public module called Pipeline Builder. Okay, so I've declared that I'm going to have a public module called Pipeline Builder. Now I'm going to go ahead and make another file, and this needs to be named pipelinebuilder.rs. Oh my goodness, is this going to pop up every time? How annoying. Well, let me see if this helps. It says that it's not being used in a thing at all. So let's just import that and see what happens. So what I'm going to do is I'm going to so I'm just declaring the dependency in main. So I'm saying, all right, this is the package that we're going to use. This is the module that we're going to use. So what I'm going to do is this pipeline builder, we're going to create it, and then potentially we're going to reuse it to rebuild multiple things. And so it's sort of going to be a state machine. So I'm going to have a few things to keep track of. I'm going to keep track of the shader file name, as well as these other bits, the names of the entry points for the functions. They do all need to be named differently. We'll get into trouble if they're not. And it turns out I'm also going to store the, we'll say, the pixel format. Okay, so in order to construct one of these, I'm just going to pretty much give some sensible defaults. So now I'm going to have two setter functions. One of them is to set the shader information, so to go ahead, set the file name and the entry points just in one go, and the other one is to set the pixel format, because why not? There we go. Nothing too exciting there, just a bunch of setters. Now what is exciting is this next function, and that is building the pipeline. This will be quite long and a little strange, especially the file handling stuff, but let's start dealing with this.
Four computers now have primary control of critical vehicle functions.
Right, so typing some stuff out, we're getting some errors. That's all fun. Well, I won't worry about this render pipeline stuff just yet, but I will need some way to get the current directory. So yeah, it says here standard environment current directory. Okay, let's use that. So go up the top. So really what I'm trying to do is, as you can see here, grab the current directory, look into the source directory of that, and then look into the the actual shader file name. And now this next part gets a lot of fun. What I'm going to do is read that file and get this source code. And what I'll do is first up, I'll import fs, file system, now we'll get some stuff, and this looks okay for now. I'll go back and modify this in a little bit, but let's keep progressing. Let's say we've loaded the file, we've read its contents, we've got the source code. Awesome. Now what I'm going to do is make the shader module descriptor. So what I've got is I'm taking that source code, which again should be a string, and I want to interpret that under the WGSL language and pass that in as the source for this shader module descriptor. Okay, now Rust is giving me an error, and it's saying it's expecting some sort of cow, not a sheep, but a cow. So what cow is it stands for copy on write, and I believe it has something to do with ownership. You know, I'm not entirely sure. To be honest, I just bash this stuff together till it works. So what we can do, it says here, what is it? We can use into. To be honest, this is a very annoying error. Here's how I solved it. So I went ahead and just up the top, we'll go use standard, yep, borrow the cow, as they say, and then down here, so again, sorry, standard borrow cow, excellent, and then down here this will not be not a string, but one of these things. Okay, and now that's fine, but I just need to cast this to the appropriate type. So yeah, I took a bit of time on that because it's a bit of a strange, to be honest, a very strange maneuver, but we basically read the file and then say, okay, and this is a copy on write string with some sort of lifetime, basically, and that's okay. Now we can create a shader module based on that source code. Okay, so as the next step, I need to describe the pipeline layout. Now the pipeline layout, if you've got your graphics pipeline, goes through the stages. Your pipeline layout is a description of which resources are going to be going through the pipeline, basically. So a bind group is a bunch of resources, and say for instance you've got your pipeline and you know uniforms is bind groups basically, but you know like which sort of matrices and structs and things are going to be bound, then you can describe those things and say these are the types of resources that we're going to take through our pipeline, and provided it knows that accurately, we can then, you know, go ahead and create the pipeline. Same thing with a push constant. Now a push constant is, remember we had a draw command encoder that was encoding draw commands. A draw command is a collection of numbers, this, okay, fine. Those are recorded up front and then submitted. With a push constant, basically what you're doing is you're pushing on a small amount of information. You're recording that directly onto the draw command encoder. It's very fast, but it can't handle a lot. And so, well, we're not even using that. So that was just my little description of what a push constant is, and when using none of them. So this is just our default pipeline layout. The next step is to define the render targets, which is really, you could think of it as, yeah, like the format that we're writing to, if that makes sense. The procedure for putting output onto the color buffer, if that makes sense. Right, so next step, I know there's lots of steps, is I'm going to, oh, we're almost done. I'm going to define my render pipeline descriptor. And then I'll use that to create a render pipeline. So I'll leave that there for now. I'll fill this in a second, but hopefully you can see that we're starting to use things that we've defined already. So we're putting in our render pipeline layout, awesome. And then we need to specify some individual stages. First up, we need to specify our vertex stage. And in order to do that, we'll put in the shader module that we loaded, but then we also need to specify the name of the shader function, the entry point, as we can see here. Now, as for additional resources, we have 0 buffers, so that's just completely blank. Okay, so as you can see, we're still chugging along. We've defined the vertex stage, the primitive assembly stage, and down here we have the fragment stage. Now note that the fragment stage is optional. Okay, so not sure what else to say. Let's keep pressing on. So I have a little bit more to define. We'll have the depth stencil, which we will not be using, and the multi-sample stuff. We're not really going to have any multi-sample stuff, so that is equivalent to basically having a sample count of 1. And yeah. And then finally, we have multi-view, which we will not be using. Okay, so in review, these are basically the defaults that we need in order to describe a pipeline. We have the pipeline label, layout, we have the stages, so vertex, primitive assembly, and fragment. And then beyond that, we have the depth stencil test, which we're not doing, the multi-sample state, which we're pretty much doing nothing, and then yeah, the multi-view. So finally, let's return the final result. We'll take the device and say, hey, create a render pipeline based on that description. Okay, so we are done with the pipeline builder. So again, just to recap, what we've done is we've defined a pipeline builder class, or struct in fact, which operates as a state machine. At any point we can tell it to store a different file name, and then at any point we can tell it to go ahead and just build a pipeline, and it will load in that source file and do what it has to do. Okay. So now let's tie everything together. If I look at my program state, in addition to all of this stuff, I also want to have a render pipeline. So I'll go down, right just before I create this thing, and I'll go ahead and make my pipeline builder. I'll then configure the pipeline builder to take the file name, okay. With my pipeline builder configured, I can then tell it to make a render pipeline. And I can take that in and use it in my construct. So at this point, I have now compiled my shader pretty much, and I've got that render pipeline ready to go. Now actually very little needs to change in rendering. If I go down to my renderer, I'm doing all this stuff. I'm setting up, you know, my drawable area, getting my image view that I'm going to render to and everything. I create my render pass descriptor. I begin the render pass. Okay, now just after beginning the render pass, let me go ahead . So I've got my render pass object, then I tell it to set the pipeline to the program's pipeline, and now I'm going to issue a draw command. So I'll say, alrighty, draw, and I need to put in the vertex range, which will be 0 to 3, and then the instances, well, I'm not really using instanced rendering, so that's just nothing, basically. And now it's going to complain. And the reason it's going to complain is some funky Rust reasoning. So what do we have here? Cannot move out of command encoder because it is borrowed. Move out of command encoder occurs here. So here's my little workaround. What I'm going to do is up here where I have this command encoder, I'm going to open a block, and then right down here where I stop using the command encoder, I'm going to close a block. And I know that's weird and doesn't really make sense, but that's Rust, I guess. Fun times. Well, let's find out if that works. Just a side note. I know that's a bit strange. My understanding of this situation is that we have this command encoder, and then I believe here we're sort of using the command encoder. But then again, we're sort of borrowing it once more. To be honest, I don't 100% understand this situation, but that at least fixed the error. So let's draw that and see what happens. Oh, actually, I shouldn't be too frustrated, because that error was 100% my own doing. So I go ahead and run this. It gives an error, and it says entry point fs main at fragment is invalid. Now, in my haste to get code out on the screen here, I sort of wrote some things, right? I wrote some variable types, and then later on I explained a little bit more and annotated them correctly. So it turns out that if I go down here, this output also needs to be annotated. This is going to go to color buffer 0 or render attachment 0, which is, yeah, location 0. Now, fingers crossed. There we go. Perfect. Okay. So, we've got our nice little triangle on the screen. Let me talk through again what we did. Like I said, there were 3 stages. The first stage was basically to build the shader code, which we've got here. The second stage was to make a state machine pipeline builder that does all the heavy lifting of building a pipeline, and if I want to reuse this to make other pipelines, all I need to do is call this set shader module, put in some different file names, and it's ready to go. This one's sort of a nightmare, to be honest. It's a heavy function, but okay, so we've got that. And the third stage was to put everything together and use it. So again, we had this render pipeline field in our program state, which was filled over here. We make the pipeline builder, we tell it which file names to load, we go ahead and construct one, and then in the rendering we did this funky thing, which again I don't 100% understand, but hey, I did it. We do this funky thing where you wrap this block up in braces to sort of scope it out, give it its own scope. Then we create this render pass, set the pipeline, and draw. There we have it. And in the end, like I said, we get a nice little triangle. There's our shader, we defined it. So there we go, hope that was fun. In the next video in this series, we're going to be uploading data to the GPU. I hope to see you there. Anyway, that'll be it for now. Bye.